In the previous class, we have seen how to solve quadratic equation by the method of factorization, by factorizing into linear factor and to find out the solution. Okay? There are some quadratic equations which cannot be factorized and which has a real solution. Okay? So, in those conditions, we need other methods. What such a method is called? Method of completing the square. Method of completing the square, how to solve. For example, see this question and we need to factorize, it's not possible. We don't have any integer, adding them I get 4, multiplying I get minus 1. Okay? So there is no integer like that. So in that case, this completion of square helps us. Okay, it has a step-by-step procedure we follow. What procedure we follow is that first thing you do, you will transpose the constant term to the other side, okay, to the right hand side. Only x square term and x term keep at the left. So it is becoming x square plus 4x is equal to 1. Then you make sure x square coefficient is 1. If not 1, you divide by the coefficient throughout and make it 1. For example, you have 3x square like that. Then you divide by 3 here every time, both the sides, so that x square coefficient becomes 1. Okay, in this question indeed x square coefficient is 1. This is first step you have to do. Keep the constant term on the side, x square term and x term at the left side. Next take the coefficient of x here. Okay, coefficient of x, take exactly half of it. So 4, I take half of it, that is 2. Square it, okay? 2 square. This 2 square means half the coefficient of x, you take and square it. So square of the half of coefficient of x, take, add both sides. Okay? So I have to add 2 square both sides. So here, right here, add half a square of half of coefficient of x. Okay, half of coefficient of x, both sides you add. So I add here x square plus 4x plus here 2 is coming, so 2 square is 4. Other side also I add 2 square. Okay, so we get here is what, x square plus 4x plus 2 square. This is nothing but the x square plus 4x plus 2 square is exactly x plus 2 the whole square. It's a perfect square actually. You can expand it and check. What is the expansion? X square plus 2 into x into 2, that is 4x plus 2 square, that is here. So always this side become a perfect. You have completed the square. So completing the square, it become a perfect square. Other side is 5. This is 5. Okay. Now I need x. So I have to get it, removing the power and all, and will go ahead. So if you have to first remove the power, what I have to do? You take the square root both sides. So taking square root both sides. Okay? Square root. Both sides we take. So when I take, this is becoming x plus 2. Now I take square root here also. Okay? So your power will go here. One thing, square root of 5 should not take. You have to take plus or minus square root of 5. The thing is, when I take the square root of some number 4, it may be plus 2 or minus 2. 2 square also 4 and minus 2 the whole square also 4. So whenever I take one of the sides, I write here what? Plus or minus root of 5. The square root of 5 means it may be plus root 5 square also 5 and minus root 5 square also 5. So both the side plus or minus. Now you move this. You need x, so transpose it to other side. This gives you x is equal to this 2, negative 2 when it goes there. Instead of writing in this side, I write just before this. So minus 2 is rational factor first, irrational factor next, like this way. Okay. So now x is minus 2 plus or minus root of 5. So two values of x. That is, x can be, if I take this positive, minus 2 plus root 5, or x can be minus 2 minus root 5. So these are the two roots of the equation. Procedure understand? Step by step procedure to follow. Okay, now we do one or two more examples to make this type very clear. Move to the other question. Second example you see, this time I have taken an equation having x square coefficient, some other number, not 1, 2. So that is why to make it different. And moreover is negative 3x, okay. First step, move the constant term other side. So you get here is 4. You have to make x square coefficient 1, so throughout divide by 2. Divide by 2 throughout all the terms. 3 by 2x, here 4 by 2, that is 2. All the terms divided by 2. Next, take the x coefficient, take half of x square coefficient and square it, add either side, okay. So add square of half of, half of minus 3 by 2 means it will become minus 3 by 4, both sides. Both sides means half of minus 3 by 2 is minus 3 by 4. So this we have to add both sides. So x square minus 3 by 2x plus minus 3 by 4 whole square. It is becoming plus 3 by 4 also. If we take squaring, it is going to be positive, but still we add. So other side also I add the square of it. This is now, as I told you earlier, this is nothing but x plus or x minus 3 by 4. X plus minus 3 by 4 or x minus 3 by 4. So because of minus 2ab coming in this time, so here you get x minus 3 by 4 the whole square. That is what the factorization of this directly. This is a, this is b, so a minus b the whole square, writing like that. So other side you have to simplify only. This is becoming 9 by 16. Take LCM, we have 32, 41 by 16. This side becomes. Okay. As I told you earlier, I need x. So take square root both sides. Taking square root both sides. Right here I take square root. Other side when I take square root, plus or minus square root of this. Or just write later when you take the square root, write plus or minus. Okay. So this step I leave it like that, and next step is becoming x minus 3 by 4 plus or minus root of 41, square root of 16 is 4. So 4 here. Okay, plus or minus 4. That is what that plus or minus side. Now you need x, transpose it other side. So x is equal to 3 by 4 plus or minus root of 41 by 4. So it is nothing but 3 plus or minus root of 41 by 4. I get x is equal to 3 plus root 41 by 4, or x is equal to 3 minus root 41 by 4. Like that, two values of x you obtain. Okay, this is the second example. One more example we do, then we will end this procedure. Okay. Come to the next example, because in all the quadratic equation you may not get roots. Okay, some questions you may not get real root. Let us see one such a question. As I told you earlier, this 3 to be transposed on the side, minus 3, x square coefficient to be made 1. So divide by 2 throughout. So x square, this is becoming plus 2x minus 3 by 2. Okay, we are completing the square now. So what do we add here? Add square of half of 2, half of 2. Square of half of 2, both sides. Half of x coefficient, both sides. So half of 2 is 1. Okay, so 1 square I add both sides. So x square plus 2x plus 1 square minus 3 by 2 plus 1 square. 1 square is 1. You can write 1. This is, as I told you earlier, this is nothing but x plus 1 the whole square. Other side is becoming, you can take LCM and that, then this is becoming what, minus 1.5 plus 1. It is becoming minus half. Minus half. Okay. So next is taking square root both sides. This step is very crucial. Taking square root both sides. Okay. So here what will happen? I take here square root, here also take square root. So here I get x plus 1, this side I get plus or minus under root minus 1 by 2. See this one. For a negative number, you cannot take square root. It will not be real number. So a negative number do not have any, negative number cannot have real square root, because negative number is not the square of any number. Any number is square, it becomes positive. So when you take it's not possible to find out the real value of this. This is not a real number. So in this step, you don't have to go further. If you want one more step, you can write and you can tell that x is equal to minus 1 plus or minus root of minus half, and you stop here only and tell the equation does not have any real root, because under root minus 1 by 2 is not real number. Under root minus 1 by 2 negative number is not real. Okay, not a real number. Hence the equation has no real root. So whenever you get negative number under root, you can stop until that there is no real root. The equation has no real roots. Okay. This is the third type. With this, you can do all your textbook questions given in the exercise. Exercise 4.3, you can do exercise 4.3. Okay. This you will do by completing the square method. First question fully. Exercise 4.3, question number 1. 4 bits are there. You can try all the 4 bits by yourself. Okay.